Moving on to the next parent function that we'll be dealing with in this course, f of x is equal to 1 over x. Now this function can be rewritten as y is equal to 1 over x, and this here is also called the reciprocal function. And it's a unique function. It's a function that we haven't seen before, and it has a lot of unique features. The first thing to notice about this function is that the x value can't be 0. Because 1 divided by 0, if you try that in your calculator, you'll get an undefined value. It's undefined. So the question is, what happens around that x value of 0? How does this function behave? Now, because this function is so unique and it's something that we haven't seen before, I'm going to use a lot more points in our table of values. And I'm going to make a separate table of values for the positive portions of x and the negative portions of x, so we could really find out what the shape of this graph is. So what I did here for the positive values was, since x can't be 0, I want to find out what's happening as we get very close to that x value of 0. So notice how I use an x value of 1, then of 0.1, and then of 0.01, just getting closer and closer to that value of 0 to see what the behavior of this graph is. So at an x value of 0.01, if we plug in 0.01 for x in the function, 1 divided by 0.01 would give us 100. And then 0.1, 1 divided by 0.1 would give us 10. 1 divided by 1 is 1. 1 divided by 10 is 0.1. And then 1 divided by 100 is 0.01. Same thing for these values here. I want to find out what's happening as we get closer and closer to that x value of 0 from the negative side. Hence why I got negative 0.1, negative 0.01. So plugging in an x value of negative 0.01 for the function, we get a y value of negative 100. Negative 0.1 would be negative 10, negative 1, negative 0.1, and then negative 0.01. Now, taking all of these points in our tables that we made and then plotting them on the graph. Now, this graph is nothing to scale, just as a heads up. However, we just basically want to find out what the general shape of this graph looks like. So, for example, we took this point 0.01 and 100, and it's up here. An x value of 0.01 and a y value of 100. Then 0.1 and 10 is here. 1 and 1 is here, etc., etc. And then same thing for the negative values. This point here represents negative 100 and negative 0.01. And then this other last point represents negative 0.01 and negative 100. And then all of the points here are these values in the table. Taking all of the points that we plotted and then connecting them, we can see that the shape of the graph looks something like this. The shape of the graph y equals 1 over x. Now again, this graph is not to scale. These points were not to scale, but in general, this is how the shape of the reciprocal function looks like. Now, one thing I want you to notice is how when the graph is approaching this x value of 0, or this vertical line, this y-axis, the function gets closer and closer to it, but it never actually touches it. And what that line represents is something called an asymptote. And an asymptote, the definition of it is basically a line that a relation or a function approaches, as you can see here, but it never touches it. So this is an asymptote right here. And notice how this is a vertical asymptote, and notice how there's also a horizontal asymptote, because as the x values are approaching negative infinity and positive infinity, they are approaching the x-axis, or the line y is equal to 0, but it's never touching it. So in conclusion, the reciprocal function has a vertical asymptote at x is equal to 0, and it has a horizontal asymptote at y is equal to 0. Now let's conclude the video by figuring out what the domain and range is for this function. And notice the domain, the x values can pretty much be anything except for 0. The x value of 0 is undefined. So x can be any number, x is an element of real numbers, but x cannot equal 0. And then same thing for the range. The y values can be anything but 0 because there's a horizontal asymptote at y is equal to 0. So the y values can take any value. Y is an element of real numbers, but y cannot equal 0. And that's the domain and range of the reciprocal function.